Alright, we're going to look at four examples here of solving quadratic equations by using square roots. This is the first method we talked about. The other two methods are going to be factoring, completing the square, and the quadratic formula. The quadratic formula actually comes from as a result of being able to complete the square. So it's actually completing the square in disguise. And I've already said too much, so let's just take a look at these square roots here, because that's our goal for this video. So I know I'm going to use the square roots method when I don't have a linear term. And the linear term is, let's say we had a quadratic function here. The linear term is the term that has just the x to the first, or whatever the variable is, to the first power. So 3x would be my linear term. We've talked about a, b, and c. The 3 would be your b. Okay, so the square root method works well whenever there is no linear term. And if you look at the first example that I have here, you'll notice that there's a quadratic term and there's a constant, but there is no linear term. There is no just x to the first. In number 2, there's a quadratic, linear, there is no t to the first. So both of these can be solved by using square roots. And this method is pretty simple. You just get the variable isolated on its own. So we want to get x squared by itself. We divide by 2. Half of 98 would be, let's think about this one, 49. So we have x squared is equal to 49. And we're going to take the square root of both sides. And here's where you have to be careful. You have to put a plus or minus sign. There are actually two answers we're going to get here when we take the square root. And I'll explain this after we see the answers. So the square root of x squared is x. And this is going to be equal to plus or minus 7. Okay. There are two answers here. There's x equals 7, and there's also x equals negative 7. It can be one or the other. And let me prove to you that that works. If you wanted to check your work, you could write the word check, and you could plug both of these numbers in for x. So if I were to plug in 7 for x, should equal 98. If I want to be technical here, I put a question mark because I don't know it's true until I check it. I have 2 times 49 is equal to 98. And that's true. 98 is equal to 98. So that checks out, right? I'm just going to sneak attack this one in here. If I were to make this 7 a negative, when I square it, I'm still going to get a positive 49, which would still give me a true statement. So that tells me that I need two answers here. I need positive 7 because that works, and I also need negative 7. So when you take the square root, there are two square roots. There's something called the principal square root, which we think of that as the positive version, and then there's going to be the negative version as well. So we need the positive and we need the negative version of our answer. Alright, so let's go ahead with that stuff out of the way. Let's go ahead and finish off the last three problems here. Try to go through them pretty quickly. Let's isolate the t. And let's take the square root of both sides. When I do square roots, remember I need the plus or minus. And so for here, I'm going to get t is equal to plus or minus 5. That would be my answer. So two answers, positive 5 and negative 5. Alright, let's flip to the next page here. Okay, and number 3, we're going to have 3n squared. Now I'm going to subtract 12 from both sides. So I'm going to have 3n squared is equal to 0. I'm going to divide by 3. So that's n squared is equal to 0. And this is kind of a special case here, because when you take the square root of 0, there's only going to be one answer. That's 0. Okay? And one more special case here. If we divide by 2, we get g squared is negative 16. Take the square root of both sides. when I do that, I'm going to put a plus or a minus. Some of you already may notice what's up here. Okay, so you're going along and you have g square root of g squared, that's g equals plus or minus square root of negative 16. And then you say to yourself, but wait a second, what number times itself gives you a negative 16? And some people might say, well, what about 4? Well, 4 times 4 is positive 16. Well, it's not that, it's negative 4 then. Well, negative 4 times negative 4 is still positive 16. So it's not going to work. And somebody might be saying, well, what about positive 4 times negative 4? Yeah, that would work, but that's not what the square root's telling you to do. It's saying you have to find the same number twice, the number being multiplied by itself. So it doesn't work. So for this particular example, we're going to say there are no real number solutions. And the reason I'm saying, whoops, that was a flub up on my part. No real number solutions. The reason we're saying no real number solutions is because there are imaginary solutions. Oh my, yes, there are things called imaginary numbers that exist, and they were created for situations just like this, where you had to take the square root of a negative. So the goal whenever you are wanting to solve quadratic equations by using square roots is, first you want to make sure that your linear term doesn't exist. In other words, if you look at number 1 again, there is no x to the first in your equation. And when you see that, you can use the square roots. You isolate your variable, and then you take the square root, and you have the plus or the minus, unless, of course, you have a 0, in which case the answer is just 0. That's method 1.